Welcome 7th graders to video lesson 2.1C. This is the third part of 4-part series, and great work for keeping up the good work and hanging in there. Today we will be ordering rational numbers. We'll be ordering fractions and decimals that are both positive and negative. So you know the drill. Make sure you have your notebook, write down all examples, and take the assessment at the end. So remember, rational numbers are any numbers that can be written as a ratio, which means any number that can be written as a fraction. And here are 4 examples of numbers that can be rewritten as a fraction, so therefore they are all rational numbers. Okay, here we go. In example 3, which is our first example, the table shows the elevations of 4 sea creatures relative to sea level. That means we're comparing all these numbers up to 0. Which of the sea creatures are deeper than the whale? So what I want you guys to get used to is highlighting the information that you need to answer. So this is what I'm answering. That's my question. The math that I have to do is something else, but I need to make sure I answer that question. So what we're going to do is we're going to take each rational number. So we're going to take all 4 of these numbers here, well 3 of them, and rewrite them as a decimal. So for 13, negative 13 tenths, I'm going to take 13 and divide it by 10. Okay, how many times does 10 go into 13? 1 time. There's 3 left over, so I could add a decimal and a 0. Bring the 0 down. 10 goes into 30 3 times, and there's none left over, 0. My decimal point goes straight up, so I get negative 1.3. Why is the answer negative? Because it started negative. Oh. In this second example, we're taking negative 2 1/5 and rewriting that as a decimal. I know the whole number is going to be negative 2. So I'm going to take 1 over 5 and divide it. 1 is being divided by 5. Can 5 go into 1? No. We add a decimal and a 0. How many times does 5 go into 10? 2 times. How many left over? 0. Decimal point goes straight up. So we get a final answer of negative 2.2. The 2 tenths just comes over. In our third example, we're going to take negative 2 over 11 and convert that to a decimal. So we know our answer is going to be negative. So I'm going to take 2, and I'm going to divide that by 11. How many times does 11 go into 2? No times, so we add a decimal and a 0. 2 goes into 20, 1 time. 1 times 11 is 11. Subtract, we get 9. Add a 0 and bring down. 11 goes into 90, 8 times. 8 times 11 is 88. 2 left over. Add a 0 and bring down. 11 goes into 20 once. And if you notice, we're going to start repeating what we have over here. I'm going to get 11, subtract, I'll get 9. So all of this is going to start repeating. And if you don't believe me, go ahead and continue. So my decimal point will go straight up, and I get an answer of 0.18 repeating. So we get a solution here of negative 1800ths repeating. So now we're going to take these numbers and graph them on the number line. Remember, all of these are negative numbers, so we want to take the number that's furthest from 0, which would be represented as this negative 2.2, and that would be the squid. Then we have negative 1.3 as we come up the number line, and that represents the anglerfish. And then we take a look at negative 0.8, which is the whale. Remember, if we take a look at negative 0.8, if I add a 0 at the end, it's like 80 cents. So negative 0.8 is the same as negative 0.80, which is even smaller than negative 1800s repeating, which is why it comes next on the number line. And then finally we have the shark at negative 1800s. So we've ordered these smallest to largest. So the question is, which of the sea creatures are deeper than the whale? So here is the whale. Who's deeper underwater? Well, there's in fact two answers, the anglerfish and the squid. But who's the deepest? The squid. Why does that keep happening? Okay, so our solution would be the squid, who is the deepest compared to the whale. We're going to take the following 5 rational numbers and we're going to order them from least to greatest. Remember, they're called rational because every one of these numbers can be rewritten as fractions. So let's take a look at our board here. I have negative 3/4, and we're going to rewrite that as a decimal. So 3 is being divided by 4. So how many times can 4 go into 3? No times. So let's add a decimal and a 0. 4 goes into 30. 4 goes into 30 7 times. 7 times 4 is 28. 28 from 30 is 2. We're going to add a 0 and bring down. 4 goes into 20 5 times. We subtract and we get 0 left over. Decimal point goes straight up. So negative 3/4 is equal to negative 0.75. Let me just clean this up for you guys. Your work should stay in your notebook. I'm simply deleting this because I only have a small amount of space to work with. Okay, we're going to take a look at the next fraction that we have, 2/3, and we're going to divide that. So we will take 2 and divide that by 3. Can 3 go into 2? Hopefully you're saying no, so let's add a decimal and a 0. 3 goes into 20 6 times. There's 2 left over. Add a 0 and bring down. Hopefully you're noticing that it's repeating already. 3 goes into 20 6 times. 18, there'll be 2 left over, and this will repeat forever and ever. So 2/3 is equal to 6/10 repeating. Okay, now our next example, we have negative 7/3. So I'm going to take 7 and divide it by 3. Notice that the denominator always goes outside. So 3 goes into 7 2 times. 3 times 2 is 6. There is 1 left over. I add a decimal and a 0. We bring the 0 down. 3 goes into 10 3 times. 3 times 3 is 9. There's 1 left over. If I add a 0, I get 10 again. So this 3 is going to repeat. So I get an answer of negative decimal point 2/3 with a bar over the 3. Oh, I made a mistake. the solution is -2 and 3/10 repeating. Okay, so my decimal point here goes straight up. So it's 2.33. Okay, and remember the bar notation means the 3 goes on forever. Okay, now we have 5/10 and 1 and 2/10, which are already decimals. So just remember that 5/10 is the same thing as 0.50. Okay, adding a 0 to the end of any decimal does not change its value. So what I want to take a look at here is, first I want to take a look at all the negative numbers. So I have one negative number and I have two negatives. So from there I want to decide which one is greater. So looking at these two, -2.3 repeating or -75/100, the smallest one here is the -2 and 3/10. So -2 and 3/10 is located, we have to estimate somewhere about here. So that's where -7/3 would be. Okay. Next we have -3/4, which is 75/100. So that is almost -1. So that's right about here. So -3/4. Okay, and now I'm going to take a look at my three positive numbers. Remember that the 2/3 repeating, the next digit that comes next is a 6, not a 0, because in this case, this number here repeats. So this looks like 50 cents, this looks like 66 cents, and this looks like $1.20. So going down the number line, I'm going to take the smallest number, which would be 0.5 or 5/10, which is between 0 and 1. So this is where 5/10 would belong. And next would be 2/3 or 66 cents, so to speak. So that would come right in here. It's right next to, again, there's a little bit of estimating. So there is 2/3. And finally, I have 1 and 2/10, which is just a little bit greater than 1. So in order least to greatest, we have, if you just look at your number line, -7/3, followed by -3/4, followed by 5/10, followed by 2/3, followed by 1.2 or 1 and 2/10. Okay, in this next example, We have 9 over 5 and negative 4 over 5. So what we need to do is convert both of them to decimals. So I'm going to take 4 and divide it by 5. 5 can't go into 4, so we add a decimal and a 0. 5 goes into 40 8 times, leaving us with no remainder. So we call this a terminating decimal. Decimal point goes straight up. So negative 4/5 is equivalent to negative 8/10. Now we're going to take a look at 9 over 5. We're going to take 9 and divide it by 5. Remember, the denominator always stays out. 5 goes into 9 one time. There's 4 left over. Add a decimal and a 0. 5 goes into 40 8 times. 8 times 5 is 40. So we have another terminating decimal. So this would equal 1 8/10. Okay, so what we want to do now is take a look at all the decimal values and order them from smallest to largest. We want to start with the negatives, and I have a few negatives in this problem. I have a negative here. Let me clean that up. I have a negative here, and I have a negative here, and this fraction is negative. So what I'd like to do is take a look at which one of these is the smallest. So take a look at this as negative $2.50, negative $1.10, and negative 80 cents. The one furthest to the left would be negative $2.50, which would be between 2 and 3. So this would be the absolute smallest number here. Okay, then it's followed by negative 1.1. So 1.1 is just a little smaller than 1, and this will fit right in here. Okay, followed by negative 1.1. We have negative 8/10. So that number is almost 1, so that falls right about here, which was originally negative 4 over 5. Be sure you use the original form when you order least to greatest. And then we have two positive numbers, 8/10, which is like saying 80 cents, and 1.8, which is like saying $1.80. So 0.8 comes next. It's almost $1, so that goes here. Oop, let me make that a little larger. Okay, so 0.8 goes here. And finally, the last one that's remaining is 9 over 5, which is worth 1.8. So 1.8 is almost 2. So right about here, we place 9 over 5. All right, so on your papers, please be sure you draw a number line and order these. Make sure you show the division that we did. Okay, so there's your solution to number 2. And if we just rewrite this neatly from smallest to largest, just read across the number line. We have negative 2.5. We have negative 1.1. We have negative 4 over 5. Then it's followed by, oh, not negative. We have, let me just fix that. We have 8/10, and we have 9 over 5. All right, let's move on to the next question. We're just going to work up to example number 3 and call it quits. So we have 5 integers, and I've placed them across the screen. And we'll take a look at the decimals later. I'm just going to group them based on negatives and positives, so later we can figure out what goes where. So I'm going to first take this negative 8 over 5, and I'm going to rewrite it as a decimal. So 8 is being divided by 5. 5 goes into 8 one time. There's 3 left over. I could add a decimal and a 0. 5 goes into 30 6 times. 6 times 5 is 30. 0 left over, so that means we have a terminating decimal. So this is equivalent to negative 1.6. And next we're going to take a look at 1 over 4. So 1 is being divided by 4. So 4 goes into 1 no times. We add a decimal and a 0. 4 goes into 10 2 times. 4 times 2 is 8. There's 2 left over. Add a 0 and bring down. 4 goes into 20 5 times. And we get no remainder. So once again, terminating decimal. Decimal point goes straight up. So 1 over 4 is equal to 25 hundredths. So what I'm going to do now is take a look at all of my negatives first and order them from least to greatest. So I have 2 negatives here and a negative here. That was strange. And I'm going to order those from smallest to largest. So when I take a look at this, it's like $1.60 negative, $1.40 negative, and 90 cents negative. So we will have negative 8 over 5 be the smallest number here. Here we go. Which is between 1 and 2, which is a little greater than half. So there's negative 8/5. Next we have negative 1.4, which is just a little less than half. So negative 1.4 would go in there. Followed by negative 9/10, which is almost 1. That goes right here. Okay. Then we take a look at the positive numbers. And in the positive numbers, I just have 1 over 4 and 6/10. So this is like 60 cents and this is like 25 cents. So 25 cents would come next. It's just a little bigger than 0. And finally, we have 6/10, which is just a little bit bigger than half, which would be right over here. Okay, and if we take a look at these and write them neatly from smallest to largest, we would have negative 8 over 5, negative 1.4, followed by negative 9/10, followed by 1 over 4, followed by 6/10. All right, guys, good job on getting through this lesson. I'll see you tomorrow.